Today is February 9th, 2023. This is my 223rd episode for C++ 17 2023 CUDA OpenGL OpenCL DBB Balkan. This is 53rd episode for vector calculus. 12th episode for surface integral. Surface integrals of vector field Flux 2. Please understand, I updated C++ library extensions offline and uploaded to my file server. Please notice the file name is February 9th b.zip. I fixed significant amount of bugs and updated, so don't fail to download updated C++ library extensions. If you haven't watched my previous video, episode 222. Please double-click. Please don't fail to watch my previous episode, episode 222, Vector Calculus 52. Click Show More, download current video source code, show in folder, unzip it, rename 223. Copy this folder, paste it in your working directory. Open up Visual Studio Code from CPP 17 2023 parallel. Open up from folder 223 flux.cpp, Ctrl V, Ctrl Home. Please understand, we created this file in our previous episode, episode 222. Also, I updated C++ library extensions offline. I corrected significant amount of bugs. Now, I will open Calculus by James Stewart, 9th edition. In our previous episode, we solved example 4. This example is by no means simple. This vector field should be represented f of r. Then we have to evaluate partial derivative of r with respect to phi, partial derivative of r with respect to theta. Then we should take cross product. Then with the cross product, we perform dot product against vector f. Now I will arrange side by side. I will fold it up. We created this file in our previous episode. Copy, paste, scroll up. I will rename simplified. Copy this, Ctrl N, paste it here, disable it. I will fan in example 4. In this example, f of r represent f of r over phi theta. This part is very ugly, so I created a member function from f. This f is described like this. This is a function that takes 3 parameters for each component. This component represents ith component. This component represents jth component. This component represents kth component. From vector field, we have to create f of r like this. F of r. With this, we can perform our operation as usual. With this, open up any compiler. cd 223 Flux clang ++scd c++20 flux.cpp ltbb12 or c.exe clsc. It should build and run successfully. Now I will simplify this part. I will comment out like this. Then copy this. Although dA, we take cross product, then from f of r dot product, semicolon, because here this is f of r dot partial derivative of r with respect to p cross partial derivative of r with respect to theta. So this represents this. With this, we can simply pass dA. We are performing this operation here. With this, we build again CLSC. Of course, it works perfectly. We have to relieve ourselves from the burdens of computational details. For such purpose, we can do this too. Instead of f of function, we can use directly like this. Or we can put this computation in the place of integrand. This integrand represents this part. By relieving ourselves from the burden or drudgery of computational details, we can better concentrate on mathematical reasoning. Of course, it should build and run perfectly.